Okay.
So for our presentation on Design a Drug, we called our drug Insomnidone. I'm Tara.
I'm Rochelle.
And I'm Elise.
So the neurotransmitter that we chose to target is melatonin, and the function of melatonin is to regulate sleep and wake cycles. Melatonin is triggered by the darkness that comes around at nighttime and causes the body to produce more melatonin to prepare for sleep. And then light in the morning decreases the melatonin production in conjunction with higher cortisol production, making the body prepared to wake up. So as sunlight enters through the eye, it goes to the suprachiasmatic nucleus and inhibits the pineal gland, which produces the melatonin in a human. So melatonin is secreted in a rhythmic pattern that corresponds to the way in which the sun sets and rises every day. So melatonin is produced in the evening around 8 p.m. It starts going up, and its peak levels are in the middle of the night to ensure that you are in deep, restful sleep then. And it's going to fall around 8 o'clock in the morning. And as you can see on the image on the furthest right, the melatonin cycle and the cortisol cycle are completely switched. So right when your melatonin starts to fall, you're going to have rises in cortisol to correspond to the sleep and wake cycle that your body needs to get a restful night's sleep and also be awake in the day to be productive.
So tryptophan is the precursor to both serotonin and melatonin. We get tryptophan from our diet, as you can see here, from grains, meat, dairy, chocolate, or turkey, anything like that. We get tryptophan. And serotonin gets derived from tryptophan, and that's responsible for our mood, aggression, appetite, sleep-wake cycles, and all the other functions you see on the screen. And then we get our neurotransmitter melatonin, which gets derived from serotonin. And that controls everything that Tara mentioned in the previous slide. So the way our drug Insomnidone works is it releases a chemical that mimics the chemical structure of the G protein coupled receptors. These receptors are what the melatonin usually binds to after it passes through the synaptic cleft. Yeah. And anytime it encounters one of these chemical, you can call them artificial receptors, but not really. Anytime the melatonin binds to these chemical structures created by a drug, it inhibits it from binding to the G protein coupled receptors, which inhibits the release of melatonin in our brain, or the signal of melatonin in our brain.
And so the effect of this is that the person who takes Insomnidone will feel more alert during the day, and if they take it at night, it'll help them stay awake at night. However, there are a few side effects. It could disrupt their sleeping patterns, so it may cause insomnia or daytime tiredness. It may cause concentration problems, forgetfulness, and increased appetite, dysregulated sleeping patterns, and faster aging. However, you should choose our drug, Insomnidone, because there's a huge market for it. A lot of college students and corporate workers would benefit from it to increase their productivity, finish their projects and assignments, study for their finals, basically just, get through the night. And luckily, there's a minimal risk of addiction. Like this drug would not be addictive, although it may affect their sleeping patterns. There aren't really like a huge negative effect in that respect. And it increases the window of time to work. So it disrupts the usual melatonin, allowing people to work or study more effectively. And yeah, that is our drug.